Welcome to PyData DC. I'm Paulo Martinez. I'm your organizer. I'm a data scientist at Metrostar Systems. Hussein Sultan is our co-organizer, and Torian, Eric, Alexi, and where's Mike? And Mike are like our also partners. They're helping to put this on. So all right, in the chat, feel free to introduce yourselves to to each other. It's still a networking event, so it's a great opportunity to make some community. Let me remind you all that this is being recorded. If you don't want to be recorded, you can opt out by not sharing your screen and not being the active speaker. The chat is not being recorded, so all of your interactions in the chat are ephemeral in the sense that once the meeting gets closed, they will disappear into Zoom oblivion. Let me read really quickly the PyData Code of Conduct for everybody. So here's the short version. Be kind to others, do not insult or put down others, behave professionally, remember that harassment and sexist, racist, or exclusionary jokes and language are not appropriate for PyData. All communication should be appropriate for a professional audience, including people of many different backgrounds. Sexual language and imagery is not appropriate. PyData is dedicated to providing a harassment-free environment experience for everyone, regardless of age, gender, sexual orientation, gender identity, and expression, disability, physical appearance, body size, race, or religion. We do not tolerate harassment of participants in any form. Thank you for helping make this a welcome and friendly community for all. So let me throw that in the chat just so you guys have it and we're being super official. Okay. And if for whatever reason you need to report a violation, you can, and I'll throw that into the chat as well. All right. Now with housekeeping over, we'll move it on to announcements. So from our partners and attendees, I guess I'll start. Let me share my screen. Cool. So Metrostar is hiring. Right now, they're looking for a DevOps engineer and a solutions architect to work at the US Census Bureau. We're also hiring a senior database administrator. So check out our job page. We're cool. We'd love to have you. That's the announcements from Metrostar. If you have any questions, reach out to us. Next up, Alexi, would you like to make any announcements? Oh, and let me give you guys the ability to unmute yourselves. All right, now let me ask again. Alexi, would you like to make any announcements?
Hey folks, this is Alexi from Spell. We're the one that sponsors the event. Really super happy to be here. A teeny tiny bit about Spell. Spell is a end-to-end machine learning platform. We basically build this stuff so that you don't have to, and we have a tool that we provide that covers model training, model experimentation, model deployment, the whole 9 yards. So super happy to be here. One pretty cool thing we did recently that I kind of want to share is we built a little demo application on Spell. I'll paintwith.spell.ml. I'll drop a link in the chat after this little intro. And this is a generative adversarial network trained on Bob Ross paintings. So you can go to this web application and paint out a little Bob Ross landscape painting to your heart's desire, and see what the model has to say about that. So cool little project I wanted to share. If you want to share some results in the chat, I'd love to take a look at them. Maybe we'll send some of them out on social. We have a little blog post here with some of our favorites so far. There's a lot of winners here, but my personal favorite has to be this crazy Bob Ross and Bob Ross machine hallucination thing. Anyway, that's all for Spell.
Awesome. Thanks. Torian, do you want me to just show your slide? Do you want to say anything about it?
Yeah, sure. Can't see the slides though.
Yeah, hold on. I lost it in the shuffle.
All right. Well, my name is Torian Dyer. I'm a technical product manager for Rapids, which is an open source project that allows you to, using very familiar PyData APIs such as Pandas, Scikit-learn, NetworkX, you can GPU accelerate your workflows. We also have spatial analytics, graph, and signal analytics, similar to SciPy.signal. We kind of benchmark, and when we release an algorithm, it's about its base level needs to be about 5 times faster, and we just shoot up to orders of magnitude. It's super simple to use, really quick to get into. You just need an NVIDIA GPU. And it's really quick to get involved, and we'd love to have you on the community.
Awesome. Cool. And then Mike's on the call, right? Mike, would you like to make any announcements? Share anything?
Sure. Mike McCarty. I'm the Director of Software Engineering at Capital One Center for Machine Learning. I don't really have many announcements other than the fact that I'm hiring a Agile delivery lead, and I'm about to post a link to that job in the chat.
Awesome. Cool. I guess like last minute, this might be a little chaotic, but anybody from the audience, do you guys have like a quick announcement? Something you can make polite and snappy? Going once, going twice. Okay, cool. All right, well then let me introduce, without any further ado, our speaker. Eric Dill is an all-around awesome dude and very big deal. He's the director of data science.
That's a little much. I don't know what a big deal, but I'll take the nice dude.
He's a big deal to me. So, and he's the director of the data science platform at DTN. His illustrious career includes being a core member of the Anaconda team, and he's a really nice guy. I really recommend you reach out to him because he will take the time to explain stuff to you because he's awesome. And he's going to talk to us today about enterprise environment management with Conda, which is awesome. To give you a quick idea about the program, he's going to talk for somewhere between 15 and 55 minutes. Then we're going to do a Q&A. And after that, we'll leave the call open, and you can feel free to pipe up, interact with us. And one last thing, so while Eric speaks, we are feeding you guys, and the way that works is you send me a direct message, I will send you a DoorDash gift card code. You put it into your DoorDash gift card field, and it'll give you a $15 credit to order some food. So you can kick back and wait for that to come while Eric gives his talk, and then we can all chow and drink and hang out together. I think that's it. Ready, Eric?
Sure.
Awesome.
So thanks everybody for coming. I am trying out a new concept here. Going to be a whiteboard talk with my iPad and Apple Pencil. So this could go horribly wrong or it could be super fun. I'm planning on posting the kind of resultant image at the end somewhere on social media or something that will have that everybody will have access to it if you want it. This is being recorded. Yeah, okay, it's being recorded. Cool. Yeah, so thanks for joining. This was originally going to be a talk at PyData Miami, but that got canceled due to the global pandemic, which is reasonable. So I've got a few slides from basically the skeleton of a talk that are probably worth going through a little bit here. Maybe 5-10 minutes of this, and then another, however long people have patience for to watch me doodle on an iPad. Please interrupt with questions at any point. I'm expecting this to be fairly interactive. Or, if there's no questions, then I guess strap in and hold on. I'm gonna share this. Again, working title, because it never actually turned into a real talk. A bit about me. Yeah, these are really old slides. Hold on. Let me update these live. So I am currently the director of data science platform. That's a huge font. Okay, well, I guess this will just be big font then. Director, data
That Dr.
science platforms. DTN. So DTN is a global weather analytics company, currently working on building out our data science competency. So I was brought here to build out our platform. You know, building from open source components like Jupyter Hub, Conda, Dask, Airflow, etc. Also been part of the Conda Forge core team since about 2017. Before that, I was at Anaconda, was a solutions architect, so worked with Fortune 500, mid-market companies, helping them do their data science transformation. I actually saw a couple of people that I used to work with at MaxPoint here in the audience. So hi, Paul and Caleb. It's been quite a while. It's good to see you guys. That was where I was before Anaconda. Before that, I was a scientific software developer at Brookhaven National Laboratory, where I was introduced to the PyData stack, and before that, I was a chemist. Finished my PhD in chemistry, and then immediately abandoned it. So that's cool. Yeah. So slides. Basically, this is the biggest problem here, right? If you don't think ahead, what you end up doing, whenever I'm sure that anybody who's written anything in a Jupyter Notebook is like, oh, cool, I've basically got this problem solved. My stakeholders are bought into this method. It's pretty much done. And you're like, all right, so it's ready to run in prod. Just one more thing. You got to deploy it. That if you don't have a platform team, if you haven't thought ahead, if you haven't faced this problem in the past, this is going to be an extremely painful step. And everybody's been there. I'm sure that everybody on this call has experienced the pain of going from exploratory work in a Jupyter Notebook or in a Python script to okay, I want to run it in prod. So common symptoms of groups of people, whether it be in enterprise or anywhere else, that face a reproducibility problem will see some or all of these symptoms. It's really hard to share your work with your colleagues. If you ever need to debug something that failed in prod, it's really hard. Actually, that was this one. Getting your code into prod in the first place is hard. Getting new folks up to speed, again, very hard. For a specific example that I had managed to detail out in this partial talk, typically when you are looking to share a Jupyter Notebook, what this looks like, right? You get the notebook from a colleague, right? Why would you be getting a notebook? Either A, they're like, hey, I'm having trouble, can you help? And so what do you get? You get a notebook in your email. Maybe you get a notebook in a Git repository, but regardless, you have a notebook. That notebook's not going to work unless you have the same environment that they have. Getting that environment spec is usually at least another few rounds to get that correct. Again, if you're in Jupyter, you got to get that kernel made. That is a non-trivial problem for anybody who's tried to create a Jupyter kernel in the past, especially if you're using Conda. Finally, you can get down here and get to the Jupyter server piece. To go into a bit more detail on these pieces, just to kind of highlight the pain. So inside the notebook, there's actually the kernel spec is saved inside of the metadata of the Jupyter Notebook. For anybody that is unaware, a Jupyter Notebook is really just a JSON file with a specific structure. And then Jupyter around it is designed to read that structure. It's an open spec. It's why you can open up PyCharm and it's got Jupyter Notebook support, and why VS Code has Jupyter Notebook support, and some people enjoy writing Jupyter Notebook support in tools like Vim and Emacs, so there's all kinds of weird extensions for those things too. But basically, the name of this kernel spec points to a specific place on your computer, or whatever computer you're currently running your Jupyter Notebook on. So if I was to give Paolo notebook, and I had used a kernel named Pandas, it would be looking for a kernel named Pandas. If Paolo's pandas environment is something completely different, or if that kernel points to something completely different, then the notebook will open up, it'll find the kernel, it'll start a kernel, and nothing is going to work. So you get these weird errors that way. Looking at what that kernel is, if you want to get it to work with Conda, it's generally a pretty painful process here. But it can work. There's a library that you can use to make this a little easier. It's called Conda, because this is just a live kind of weird talk. I'm gonna write that one down if I can find my text box. There we go. So github.com, so that's really small. GitHub.com/ oh goodness, Velasys digital media / Conda. That is what's used to write this horrendous blob of text in the middle of a JSON file. So if you wanted to share that environment and you want it to be extremely precise, this is what you need to run at the command line, which is awful. Or you get an environment.yaml spec or something from a colleague. In reality, nobody cares about this. This is a thing for the machines to care about. What you care about is the things that are bolded and in red, maybe, right? So you as the user are like, hey, I need these. I need NumPy, I need Dask, I need Pandas, and I need S3FS to execute this notebook, for example. And so basically, all of this is to say that unless you kind of have solved this problem, or unless you've faced this problem in the past, unless you've got somebody at your organization who's thinking about how to solve this problem for a large group of users, it becomes very painful very quickly. So that's what this talk is about, is how do you prefetch a few of these problems? How do you get out ahead of this and design some infrastructure, design some workflows that mean that this is not as painful for users? Yeah, so I think I'm going to switch gears. I'm going to page through some of these other slides real quick just to refresh my memory. Yeah, okay, there's nothing particularly interesting there. Please stop me with questions whenever. Again, this is mostly a group journey here. So I am now going to try and share to my iPad. So give me a minute. So if you are trying to solve this problem, you are going to need a couple pieces of infrastructure. First things first, you are going to need a Git repository. You likely have Conda packages that you're going to want to build internally. These are captured by a spec. It's called the meta.yaml. This is what Conda build uses. Go the other direction. Meta.yaml. So Conda build uses these meta.yamls to produce a Conda package. You will want to build your own Conda packages internally if you have internal source code that you want to package that you don't want to make available externally. If you've got an open source library, first question is, if you need a Conda package for a Python library and it doesn't exist, you've got two options. Can you package in a Conda Forge? Package on Conda Forge. The answer to that is yes. Great. Then you can do that and it becomes available on Anaconda. This is getting a little cramped already. Like I said, this is going to be an adventure. And with the nerves, my handwriting is not as good as it usually is. Anaconda.org. So you can then Conda install from anaconda.org. If the answer is no, then you're going to want to package it internally. In order to package it internally, you need a Git repository that contains these meta.yamls. You need some CI/CD. What you're going to do in that CI/CD, you're going to, install Conda. You're then going to install Conda and Conda build. You are then going to, Conda build your package. And then you're going to push it somewhere. Where that is entirely depends on your infrastructure and hopefully what your ops team is already managing for you. So that could be somewhere like, you could use anaconda.org if you're feeling very brave and wanting to rely on a free and open platform. You could use Anaconda Team Edition. If you want to pay Anaconda, you can use Artifactory, etc. Basically, you need an artifact store. So these Conda packages have to be somewhere that you can install from them. There's one more piece of the puzzle here that as soon as you make Conda packages available internally, you're going to need to modify the Conda RC to point to this channel, to point to where these packages are. Point to these packages. Packages. Okay. In terms of what that looks like, you can see some kids' music on here because I have a 4-year-old. Okay. So I already looked this up. So you can go to the Conda docs. What you want to do in here, you want to make sure that all of your users are pointing to wherever that Conda package landed so that they can install from your internal Conda packages. Again, happy to go into whatever detail people are interested in, but at a high level, assuming that you control some level of systems or assuming that your users actually listen to you, which is, not necessarily an accurate assumption, but one can always dream. You will be able to tell your users to modify their Conda RC to point to wherever you're storing Conda packages. So at this point, users can now do something like Conda install my custom package. Like, let's say that this is a very specific, library that does some level of automated feature engineering that hasn't yet been packaged on Conda Forge. These things happen fairly frequently, or it's an internal library. Conda install, my company library. So at this point, you've enabled your users to install Conda packages that they couldn't do previously. So that is not the most interesting step by any stretch. It is a necessary thing that probably needs to exist. Immediately after that, we're going to get back to that problem of wanting to start. Yeah, heard somebody. What's up? Was that an accidental unmute, or was there a question?
I think it might have just been accidental.
Okay, cool. Okay, so in my past life and current life, or past jobs and current job, I'm responsible for building out a platform. So ultimately, what I care about is being able to, so I've got Jupyter Hub. Let's use a different color here, orange. So I've got Jupyter Hub for folks that have managed Jupyter Hub. You will know that there are a couple pieces here. There's an authenticator that is not relevant to this talk, but it's pluggable. It lets you decide how you're going to auth your users, things like SAML or local auth or OAuth, etc. And then there's a spawner. In order to get single user Jupyter servers, you need to configure a spawner. Those things can point to, you've got a cube spawner, so you can spawn servers into Kubernetes. You've got a system D spawner for spawning locally. You've got a, I think another interesting one that's not used that much is a Fargate spawner. If you're on AWS, you can launch your single user servers into Fargate. For two of these, all right, let me, hold on. How do I do this again? I need to make this canvas a little bigger. Okay, hooray. Bigger canvas. Okay, so for my system D spawner, I need a Jupyter lab environment. For these two, I'm going to need Docker images. And for Jupyter Hub itself, depending on if you're on Cube or if you're on local, you're going to need more Docker images or a Jupyter Hub environment. So basically at this point, you're now needing, I'm also going to use blue. You're going to need more environments or more Docker files or more Docker images in order to make use of Jupyter Hub and to enable your users to start doing things that are not on their own laptops. So going all the way back over here, you're going to need to extend this Git repository to now not just build, or it doesn't have to be the same one. I tend to do all this stuff in the same repository because it gets complicated to do it in too many of them. You're going to start capturing Conda environment specs, so env specs. And these can either be the environment.yaml, or they can be construct.yaml. Technically, you can also use a requirements.txt, but please don't. It'll make you very upset in the long run. So this is optionally the same Git repository, maybe not. But similarly, you need the same thing, CI/CD, right? Kind of the same thing as above. You need to install Conda, env. Actually, that comes with Conda. Constructor. Optionally, if you're using the construct.yamls, you need to build the environments with something like Conda. I'm going to write a backtick for the first time in maybe ever. Usually use a computer for that. Conda create-f, env.yaml. That'll go and create that environment, and then optionally also create a Docker image. For any of you who have done CI/CD, you know exactly how much work I'm blowing over when I just quickly scribble all of this out. If this is something that you're interested in, I'm happy to talk, at whatever length you would like later. Optionally create a Docker Docker image. Okay, so that's the CI/CD for building an environment. So you need to store a Docker image. So these go in places like, again, Artifactory. You can use Quay.io. I think there's a few more, or there's a bunch more. If you're writing your own environment, I would do something like, oh no, I totally skipped Conda lock. Okay, 1A. use Conda lock before you do this. If you Google what Conda lock does, that'll probably make sense. If it doesn't, Google it and then email me or ping me on Twitter or something. I think there's enough contact info that you can get a hold of me. Once you build the environment, you need to store it somewhere. Store and you know, S3 if you're on Amazon, Artifactory, etc. Again, they just have to end up somewhere. So we've now got environments and Docker files. There have been no questions, and I've been talking for a while. I am surprised at that. So either everybody's following along great, or everybody's eyes are glazed over, and they're, you know.
So I'll ask a quick question. I wanted to interrupt you earlier, but you then just said, "Oh wait, Conda lock," and I was like, "Conda lock? That sounds like a thing I should just shut up for." Okay, so question for you is that you said optionally build a Docker image. Why is that optional?
If you are not using Jupyter Hub on Kubernetes, or if you're not using a Jupyter Hub spawner that uses Docker images, or if there's not Docker anywhere else in your infrastructure, then you don't care about Docker.
And we could just still use the Conda environments.
Yeah.
Correct. Okay.
Yeah. So then basically you use, okay, so I'm going to attempt to now draw a line between these two. So basically you then would be pulling Docker images, pull custom built Docker images. For Jupyter Hub, for your Jupyter spawners, for your single user servers. If you are not using Docker, well, in either, so if you're using Docker, then basically these Docker images would go into your Jupyter Hub config.py. So basically you've got a Jupyter Hub config.py. And so inside of that, you're going to specify the Docker images. To spawn user servers. That's totally chicken scratch. S-E-R-V-E-R-S. All right. So there's a huge question mark around what deploying all of this looks like. I'm just gonna write a giant question mark because that is so specific to every single company that that's like a couple of months long consulting engagement to go and solve that for a given company. I think this is actually what Hussein and Paolo are doing for the US government right now. So I am gonna skip over all of that and basically assert that you use these Docker images to spawn Jupyter Hub. Either you do this with Ansible and Docker Compose, maybe you do this with CloudFormation and AWS or Terraform and whatever you want for Docker images. Kind of similarly, if you're just using these environments, but another thing to consider is that if you want to make use of these kind of pre-baked Conda environments, you'll also probably want to write a small library that basically gives you this interface that looks like. So because I work at DTN, I'm going to use a DTN example here. So DTN install my environment name, env name equals version. And that will go and pull the environment name that's stored here and put it on disk somewhere. So as you're deploying Jupyter Hub, as you're deploying Jupyter Hub and creating your spawning infrastructure, this command then becomes part of that deployment. And so we've gotten through a lot of infrastructure. At this point is kind of where the interesting stuff starts to happen. Conda lock allows you to, let's see, I'm gonna switch to red. Actually, colorblind, I'm gonna switch to purple. Conda lock allows you to, so allows per platform solves. So basically, I can specify the dependencies that I need way over here in an environment.yaml. I can use Conda lock to go ahead and pre-solve that environment for Windows 64, Linux 64, OS X 64, etc. And what this means is that now I can start to solve that cross-platform problem where if I've got users running on Windows and users running on Linux and users running on Mac and production is Linux, we can all use the same environment, which really starts to solve that really annoying problem of how do you do cross-platform compatible stuff. The other thing that it starts to unlock is now that you have. So basically, what I would hold on. I'm going to close my office door because I just heard my kiddo start screaming. Give me 1 minute. Okay, sorry about that. What this starts to let you do is, you keep a data science environment. So ds.env YAML. This thing very rapidly grows to about 50 to 60 different specifications of various packages. I can see Ben talking, but I'm assuming he's not accidentally talking. Okay, sorry. So basically, you keep a standard environment for your users. Things like pandas, NumPy, specific versions of those, scikit-learn, Dask, yada, 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 Bokeh, Altair, all of these different visualization libraries. You make that environment available to all of the users. Everybody starts to use the same environment. It means that collaboration becomes easier because everybody's got the same environment available. You don't have to solve that infrastructure problem of like how do I properly share wildly different environments, or the real pain point is how do I share like subtly different environments where maybe it's like a minor version of Python that's causing problems. What this allows you to do is get everybody on the same environment. Again, which means that sharing is easy. It means that those environments can be available wherever your users need them, on their laptop, on their VM, on Jupyter Hub, somewhere else in prod. It means that you now have the option of defining what prod looks like. So prod now looks like an environment name. So let's say ds equals 1.4. So that's your environment version. Actually, I'm going to write this out as environment. Env name. So i.e. ds is 1.4. The kind of entry point. So what needs to run in prod, right? Is this like a specific path to a file, like my script.py? And then, if you're feeling very generous, the runtime specs. So amount of RAM, CPU, GPU, etc. And so then it now becomes extremely trivial to deploy into production because you've already got all of the environments. Your users know what they need to run, and your users probably have a sense of what the specs are. But if they've already been using this data science environment over here in Jupyter to do the deployment, then actually deploying to prod is trivial because they don't need to then go back and refigure out, okay, crap, like how do I actually go and figure out what are all of these libraries that I'm going to need? What are the 16 libraries that I Conda installed during this evaluation? That is one of the kind of pieces of magic. And then finally, because all of this is running in prod and because this environment is easily specified, it also makes debugging what prod looks like super easy as well, because you're not creating an environment. You don't have to go and write, oh, Conda list my environment in prod to figure out what versions exist there so that I can then recreate that environment locally, yada, yada, yada. If you're listening to this talk and you haven't had any of these problems before, then I consider you very lucky, and I'm actually pretty jealous. Actually, I'm not jealous because this is really interesting stuff, and I've kind of made my career around solving this specific problem. But yeah, you know, there are a number of other interesting kind of cases that this opens up. It lets you very easily run Jupyter Notebooks in production. So like I pointed out earlier, the Jupyter Notebook actually saves the environment name, the kernel name that it last executed in. And so if you give unique kernel names everywhere, then you can run that same Jupyter, you can inspect that Jupyter Notebook, you can get that kernel name out, you can all automatically, if you have, so if you have, let me just write that one down because clearly I'm not doing a great job. Jupyter in prod. What? Whenever I say this to my ops team, they look at me like I am completely insane. And yeah, they're not necessarily wrong, but you know, it's an interesting way to run stuff in prod. So basically, you need unique kernel names. There are a couple of ways to achieve this. If you just do env equals version or env underscore version or something, because you as an infrastructure person are controlling all of this, you get to decide what that env or what that kernel spec looks like. You can manually create kernels. I would really not recommend doing that. It's pretty painful. There's a nice project, NB Conda kernels, that I am using in my production system that will look at the user's Conda RC and automatically find Conda environments and automatically create kernels for you, which is awesome. And it does that via the environment name. So as long as you give the environment name something like your env underscore version, this is going to work. So if you're doing this, then a user can submit a Jupyter Notebook to something like an Airflow or whatever, or a, yeah, I'm just going to continue to use Airflow because it's the easiest one. Let's use a different color, teal. So you submit this to Airflow. So you need the Jupyter Notebook, and this will be my last point, and then I'll be all done. Jupyter Notebook and probably the schedule, you know, daily, etc. And you need the runtime specs. So the same as here. And then what you can do, so you can inspect this Jupyter Notebook, get the kernel name out, then you can go all the way back over here and say, I know that, okay, so, okay, again, this is an adventure, but this is fun. Or I'm having fun. I hope everybody else is too. You can get the kernel name, then name and version, or get the kernel name, parse the version, I'm just gonna talk. So get the name, parse the version, and then, so get the name, parse version, and install from S3 bucket or wherever you're keeping them. That is this thing all the way over here. So that's this one. So all your user has to do is write a notebook and tell you when to run it and what the specs are, and you can figure out the rest, which means that you can go run that notebook anywhere. You can run it in Kubernetes, you can run it on ECS, you can run it on some beefy VM. Yeah, you basically by walking down this path, obviously customized for what it is that you're trying to solve for, your users can basically stop caring about environments and spend more of their time doing data science or doing analytics or writing libraries or APIs and doing whatever it is that they want to do. Because I guarantee you that none of them actually want to spend their time solving environments and trying to figure out, the weird edge cases of Conda, et cetera, et cetera. So yeah, thanks for listening. This was fun. I will be happily taking questions from anyone and everyone.
Awesome. Thank you, Eric. So now questions. I'm sure some of you at some point thought, wait, what? So
Sure, it's like 5 minutes in.
yeah.
Like, what did I just sign up for? What is this whirlwind? And if there's no questions, then we can go straight to happy hour. That's fine too.
Well, I'm already drinking, but I have a question. So you
so
said the unique environment name, right?
Yeah.
You mean the unique per user or unique?
No.
Okay, tell me more about this.
As long as you can, I mean, unique here.
Okay, so each environment is versioned, is like kind of what you mean there. Gotcha.
Yeah. If you can capture so you need to version your environments here. Version the environments. This is not necessarily something that the environment spec does out of the box, but this one does. If you use the construct.yaml, then you get versioning out of the box. But the point here is that when you create the environment on disk, it has the version number in it, and it always maps back to a unique environment in your environment storage platform. Then you can parse out what the user's using to run their code, which means that you can automatically do a lot of great things. Like the path to prod becomes trivial.
Yeah. We have a question in chat. What do you mean when you said submit Jupyter Notebook to Apache Airflow?
Yeah, yeah. Go build a system that lets you do that. Really, is what I meant. Let me pull up chat so I can watch along chat. Sure, blame on the 4-year-old. Nice. Glenn, what do you mean? Yeah. So, in my mind, what that looks like, what that means. Oh wow, I can make this pretty big. So, when you submit to Airflow, I mean, ultimately, what you need to do is kind of goal is to get the notebook or script or whatever. Really get the DAG. Well, okay. So there's two different things here. One of them is that I skipped over, and I appreciate you bringing this back up. That was Glenn. So thank you, Glenn. So there's one other piece that you should know about. Papermill is a Netflix library that lets you parameterize and run notebooks. So basically, the way that I've set this up in the past is, and trying to dig this out of the recesses of my memory. So don't take this literally, but it'll be pretty close to what you would need to do. So the Invocate, so you can use Papermill as a library. So God, how did I do this? There's like some little piece of magic in the middle there that lets you have Airflow treat a folder full of notebooks as things to execute, and you can like attach metadata to those notebooks. Yeah.
So I think the metadata is a cell tag, and like that's how you would parameterize it. Is that what you're thinking?
No. So for Papermill, the way that you parameterize it is you use the first, so like the first cell of the Jupyter Notebook. It's going to look like, timestamp is, something. Data source is something else. And then, so the first cell of your notebook, you define the parameters. And then Papermill, let me see if I can actually just pull this up. Papermill Python. So Papermill gives you the ability to, come on. Usage. Execute.
Launch binder.
Okay. So yeah, so this is how you would use it as a library. So you basically put some sort of code path or some sort of code in this in an Airflow DAG. Sorry, to get back to your question, when I said submit a Jupyter Notebook, what I really mean is like somebody at your organization needs to write something that allows a user to effectively give you a notebook, a schedule to run it on, and the any other runtime parameters that are needed, and then you can then go and figure out the rest, which is at this point like really the environment. I mean, you're saving a little bit. You could also ask the user to specify in the environment that they're going to need, but there is some non-trivial machinery in place that you need to write to then take that notebook and then go and execute it. But the point is that the user doesn't have to do that. Your users don't have to be experts in Airflow and scheduled jobs, or that. So that was definitely kind of a hand-wavy answer, but it's also a complex problem. So I'm going to assert that that's good enough, and would happily take a follow-on question from that one.
I guess I've got one.
Later. Oh, hey,
so
Andrew.
hello.
So I work with Andrew in my current job. So just, in case there's anything snippy that goes back and forth, that's why.
Yeah, so these questions are in no way related to anything we're doing whatsoever. So one of the problems I've had with Python packages with other, environment package management setups is the sort of capture of upstream dependencies. So a lot of Python packages, when you're dealing with like geospatial libraries, OSGeo, GDAL stuff, they might depend on upstream libraries that aren't actually Python packages. What I've always done in the past is tie that versioning of those upstream libraries into, the Docker file itself, which it sounds like is sort of a good option here. Does Conda itself have any particular functionality or best practices when it comes to actually capturing that information?
Yeah, so Conda is not a Python-specific package manager. Yeah. You can use Conda to install all kinds of crazy stuff. You specifically called out GDAL, which was really just throwing me a softball, which I really appreciate, Andrew.
No problem. Anytime.
Yeah. Okay. The not softball part is me trying to edit a URL on an iPad. Nope. GDAL. So you can actually Conda install GDAL due to the heroic efforts of a number of people. I am not included in those people. I am purely a user. But you can Conda install GDAL, which basically solves that problem, right? Because I think what you're pointing out is that in past lives, you've had to apt install or yum install GDAL and probably do some other linking and. But yeah, so there are people that have basically turned GDAL into a couple of different packages that you can make your library depend on, and then you'll just have GDAL in your Conda environment, and you don't need to have anything on the system.
Perfect. That was a beautiful answer. Thank you.
Sure.
That question has to be a plug, right? Like,
I really, we didn't. I swear we didn't talk about any of this. I actually let Andrew know about this talk. I was like, oh, I haven't told anybody at work. Crap. Let's see. Timestamp on Slack is 5:16.
yeah, right.
Yeah.
That airflow answer and like this answer, there's like night and day, man.
Well, right. Well, one of them was easy. It was the GDAL one because it already exists. The other one was something that like I just kind of threw off the cuff. But yeah,
Hey, I'll send you my PayPal after this.
Thanks, Andrew. You're the best.
All right, before we go totally into happy hour, any other questions from the audience?
I have a question actually. You know, I'm kind of interested in, there's these two universes I kind of know about. One is, I have some middleware that I want to install, and I'm just going to like create a private pip package, and I'm just going to install that to get what I need. The other universe, which is I think the one that you've described here, is, you know, I'm an enterprise organization. I have some very serious packaging needs that are not met by, you know, just using the PyPy. And so I go through this process of standing up the infrastructure necessary to you know, all the infrastructure that you showed in these slides to create an enterprise Conda package management environment. I'm also interested in kind of the world in between those two, right? Like how easy or how difficult is it for me? Like, you know, I have some middleware package that I'm interested in that is too complicated to put up on PyPy, but I've only got like one or two of these. I don't want to go through the entire process of setting up all this infrastructure. How difficult would it be for me to just kind of have a solution for that particular use case?
Yeah, this is not step one, just to be clear. I think that definitely bears highlighting in bright red. So when you say middleware, could you elaborate just a little bit? Because like I feel like there's a very specific use case in there, and you know, if you work at like a bank or something, I understand. If you can't, that's totally fine.
Yeah, from my, well, I work at Spell, and so I'm asking because you know, we have clients that use our platform, and they need to set up access to you know they're a bank or they're you know, they have internal infrastructure, and they've written like these Python libraries which are designed to make access to the internal infrastructure easy. And to, you know, kind of give you a medium to do that. But at the same time, that stuff needs to stay private because obviously it's infrastructure specific. It's like PII or it's, you know, value prop for that company. And so they need a way to install that in their Python environments.
Yes.
And PyPy might not necessarily be the solution for that.
So as long as you don't have anything that's compiled in there, like basically if it's a fairly simple Python package, then you can just layer on, you can combine pip and conda, but only in the order of you create the conda environment first. I just realized that I've still got this really goofy video thing up. I'm so sorry. That was not my intent at all to have this up the entire time. So hold on 1 second. Let me turn this off. Okay, there we go. Yeah, so sorry. So basically, if you create a Conda environment for your users that has kind of all of the things that you'll assume that they need, scikit-learn, TensorFlow, NumPy, Dask, Altair, yada, yada, yada. And there's just a few specific Python libraries that your individual bank customers are going to need, then you can just layer those on at the end with pip. And so kind of at runtime, like having folks start from like hey, like here's the pre-canned environment that has most everything and is the, you know, multiple gigs and multiple minutes of time that it would take to install. And if you just start from there and say, cool, like what are the other packages that you're going to need to install, and just layer those in at runtime, that's actually pretty quick, and might be a viable enough solution. Like as long as you can you can do this piece here, this conda install or pip install at runtime, and users basically don't care because it's fast enough, stay here as long as you can. Because it's I mean, right? Like this is not a small project to go and undertake by any stretch. I don't know. I'm happy to take a follow-on question there because like this is like a specifically interesting problem that I want to dig into a little more. And I'd be happy to do that kind of later or offline.
Well, I think the problem, I'll turn on my video. I think there's a problem there that's, it's kind of like, it's especially important for data science, right? So you have this spectrum between like if you use one-off scripts, your notebooks, and on the other hand, you have your formalized packages, your PyPy, and even a Conda package. That is a form of kind of formalization of what you're working on. Mm-hmm. It's that middle ground where I don't want to set up all this infrastructure, but at the same time, I want it to be reproducible.
Yeah.
Right. So I've explored this a lot.
Mm-hmm. What'd you find?
It's basically what I want is something that's between Conda dev and Conda build. That's what I want. It doesn't exist.
No, it doesn't. That's it'd be great if it did.
Well, if you're interested, I've got a solution, but it's a discussion. It's quite a discussion.
Yeah, there's no magic bullet that solves that problem. Or at least I'm not aware of one. Give
everyone a Docker image.
Sure.
Well, as long as they're happy downloading many gigabytes, it's fine.
Sure, as long as every single user wants to become an expert in how to build a Docker image, or at least good enough at building a Docker image that you don't end up with just hellishly complex prod where you can't debug anything because you don't know what anything is running, and you've got every single version and you've got the outer product of pandas, NumPy, TensorFlow, scikit-learn running in prod. Yeah.
I mean, if you ask me, that's not a good practice to just have this data science mega image. The more what I've noticed is the more packages you have, there's more risk of having conflicts, right? So you really want to minimize the number of packages that you want to use for whatever you're doing.
So just take a discussion point there. Would you create many environments? So the idea behind creating a standard data science environment, and that's what we do as well as Metrostar right now, and we're just a small team, also not a lot of differentiated use cases. So how do you manage that multiple environments that are lean, but now you have thousands of them? That's a question for you, Majid. Please. I mean, not even a question; it's just a discussion.
That's an infrastructure question. That's that's managed by all these asset managers, right? I'm not
like the Artifactory.
The Artifactory. Okay. And that's not what I'm interested in. I'm interested in that middle ground between I need it to be reproducible, but I can't. The problem is with the skill set of a lot of people working with data. It's just probably if you're making a notebook, you're probably not one of those people that care about making it a package, right?
Right.
That's what I deal with all the time. Figure out a way to smooth that process between the one-off notebooks and the packages. That's where data science. That's a pure data science problem, right?
Right. Well, so you've
got decades of software engineering solving the packaging stuff, right?
Mm-hmm.
You can always rely on that, but there's that middle ground that I'm talking about.
Right. So the whole point here is that you let people stay where they're comfortable, either in a Python script or a couple of Python scripts, and then your packaging problem is basically get a couple of Python scripts to the right place with some metadata, and then the infrastructure team can write tools to figure out the rest. Right. Stay in the Jupyter Notebook, and all of the interesting code lives in Jupyter Notebooks and in internal packages that your more software engineering savvy team has written, and that's a very thin icing on top of a very thick layer cake of all of the open source libraries that we all use and depend on. But the whole point here is that like data scientists should never have to run Conda build, because that's not a skill that I value in my data scientists. I don't think anybody does. I think we call those people, who knows what we call them, but I mean, I'm one of them.
I mean,
Hey,
it's also, there's also this, I'm working on a project, and like, it's good to have like different isolations for the different parts of the project, right?
Mhm.
It's almost like I've got my infrastructure on the project level than I do on the enterprise level. That's what I'm interested in.
hey guys, I just want to read a few questions that are in the chat, and then
Sure.
you can like just integrate them as.
Yeah. Definitely stick around if you can, Majid.
Yeah,
So
I've got some ideas there.
Glenn wanted to know if there are any cool tools or packages that you are excited about coming out that we can run at home to better manage Python 3.x environments. Think. And then Michael Spencer said,
All right, let me just do these one
Sure.
by one. Tools, packages, etc. that I'm excited about to better manage Python 3 environments. I mean, managing Conda environments for an individual user, like Conda. I mean, that like not intended at all to be flippant here, but like basically Conda, you know, I mean, it's like, it was designed as an interactive way to manage some complex dependencies in the Python world. Like it was designed to solve the like, oh, not every user should have to have Fortran compilers on their computer to install SciPy. There's a few things that kind of sit on top of it, but they're very early, and most of them are more geared towards these kinds of problems, anyways, of like all of the enterprise style problems. Michael, as a relatively new programmer and a complete beginner to data science, I ran across PyInstaller, which seems to be able to easily create an executable and handle the environment issue. I guess if you don't need the notebook functionality, thoughts on using PyInstaller to handle the environment issue. PyInstaller is very similar to Constructor in that what it does is it creates an executable that you can then run to do something, as far as I understand it. PyInstaller basically gives you the environment and the entry point that you need to run into, like, it basically turns a Python script into a binary with all of the runtime that it needs behind it. You could, I'm basically talking about doing pretty much the same thing, but more tailored to kind of all of the different bits and bobs that exist inside of an enterprise that, you know, you're generally encouraged to make use of. But yeah, it's a similar type problem, but this talk was not geared towards an individual user by any stretch of the imagination. The important things to take away for an individual user are, I mean, again, I'm not trying to be flippant here, but basically like that there are different parts of the Conda ecosystem, right? That there's Conda build, that there's this Conda env thing that you can use constructor, and kind of some of the challenges that you may or may not face. Yeah, exactly. So hobbyist versus enterprise. Nathan says, that's the takeaway for me. Data scientists should not have to spell Conda build. Yeah, like hopefully you'll have like one on your team that's like super into this kind of stuff, or at least if they're not like super into it, they at least appreciate the need, and you can leverage them to kind of be, you know, helpful to the rest of the team. Has there been a shift of users adoption to Google Colab versus Jupyter Notebooks? I am ill-equipped to answer that question. I know that there is an interesting project on GitHub. What's it called? Hold on. I'm going to look this one up. github.com/parenti. It is called NB estimate, and it is an estimate of the number of notebooks that are currently on GitHub. View the latest report. Okay, So in terms of how many notebooks are there on GitHub, we have an exponential curve. I plus or minus a little bit. How many zeros is that? 1, 2, 3.
That's
4,
8 million.
5, 6, 8 million. Okay, so we have crossed the 8 million notebooks threshold on GitHub. I am relatively certain that Google Colab is probably an interesting data point, but does not, people are still using notebooks. However, they've been using them for a long time. But again, I am so ill-equipped to answer that question that you should take all of this with just like, oh, neat, a project that shows me how many notebooks are on GitHub, and not really read too much more into it beyond that.
I believe Google Colab might be the only place where you get free GPUs.
They give you free GPUs? Those things are
Or
so expensive.
Something for like whatever they call it.
That's bananas.
Mhm.
Okay, low time Python coder, just speaking of Julia Lang, as soon as I installed the Julia package that enables the Julia kernel Jupyter, which then launched Conda to install Jupyter, any insight into managing combined Julia/Python environments? Yeah, so I think there's some interest from the Conda Forge team around having better Julia support. I know that my only insight at this point is that we hope that it gets better soon. It's kind of the best that I can tell you. I think some of our core team has reached out to the Julia folks to get a better sense of like if there's interest in kind of making a Julia package that's available on Conda Forge that then gives you access to, pull Julia packages down through the native. I think there's a native package manager in Julia. Is that right? Okay, yeah.
This is why.
Sorry, go ahead.
Oh, I was gonna add, like, this is why VC funding is bad, right? Because you gotta have your own package managers.
Is that a dig at Anaconda?
I mean, this is how it all happened. I mean, Anaconda is the best package manager. Don't take me wrong.
Well, no. Like, just to be clear, like, I am also not like, I don't like, this is not a religious battle for me of like Conda versus pip versus whatever. Like, Conda was just the first one that solved the hard problem in 2013, and I really haven't looked back since then. Absolutely. I mean, people that use pip and poetry and stuff are usually very happy with them, and this is not like, this is really a statement more around how I view Conda and its use more so than like there's no subtext here of like, and pip sucks, right? Like, there's not like, that's not a, every tool has their place and every tool is effective when you use it as it's intended to be. I mean, hell, pip plus Docker files is fantastically successful, right? Like the place that pip starts to break down is when you need to do it interactively and when you need to combine different libraries that kind of lie to you about how carefully they've been compiled into wheels, right? Like pip installing TensorFlow and NumPy and Conda also trying to manage, like, there's like weird stuff with some of these libraries, but I mean, by and large, this is not a, like, if you are using pip and whatever, maybe Docker files and poetry, and you love it, keep using it. Like, switching to Conda if you're successful on pip is like the worst choice that you could make right now, for sure. I feel like that needed to be said at the beginning, and I didn't say it, so I'll say it now.
Also, Conda TensorFlow from the Conda Forge was broken like last month.
That does not surprise me. Have you seen how hard it is to build TensorFlow?
But pip was not. Pip worked. That's because Conda had installed
Google
all the
uploads the pip wheels.
That's also,
and they can use their weird Bazel build system to make TensorFlow work. But yeah.
So cool. Conda is a community operated thing. So like, that's
Conda Forge is a community operated thing.
Exactly. Yeah. So I think absolutely. Do you want to talk a little bit about the distinction between that and the Anaconda channel?
I mean, I can. It sounds like you've got some insight there.
About that because I didn't really know what the difference was, and I was always defaulting to. I was favoring anything that was Anaconda over Conda Forge.
Mm-hmm.
No.
So if you're familiar with kind of the CentOS stack, right? Like CentOS, Red Hat, Enterprise Linux, and Fedora. Those are kind of going in order of decreasing stability. Or no, sorry. RHEL and CentOS are functionally pretty similar. Fedora is like the developer bleeding edge version where they, do a bunch of iteration and new testing, and then RHEL will kind of freeze Fedora at some point, and then that becomes the next version of RHEL. It's not the same, but it's analogous to the Anaconda defaults channel being the RHEL and Conda Forge being the Fedora. There's lots of iteration. I mean, the Conda Forge team makes a valiant effort in keeping the ecosystem functional and not broken. But there's no guarantee because it's very much a user-based community. All packages on the Anaconda channel are built by Anaconda. They're built on their secure servers. They're uploaded to their S3 buckets directly from their build machines. Everything on Conda Forge is done via kind of by hook or by crook, to be perfectly frank. We've got a bunch of weird ARM machines that build ARM packages. We've got OSX workers on, I think, Travis CI that build all of our OSX packages. We've got, or maybe that's on Azure now. Conda Forge has like 200 parallel builds enabled on Azure to support it. But like basically, Conda packages come from kind of many of the free or many of the public CI services, right? So I mean, it's all built in the open. You can go and inspect all of the logs. We do, a reasonable job at making sure that the packages are secure, going from the CI system up to anaconda.org where people can install them. But I mean, Conda Forge doesn't own any infrastructure. I think we might be buying one of our core team a laptop so they can finally build Qt. But that's the first piece of infrastructure that Conda Forge is going to own, is a single laptop. It's otherwise just, I think there's 23 people on the core team. I think there's somewhere in the order of like 2,000 different individual contributors. But basically, any individual can go and make a Conda package specification. That's the meta.yaml. Submit it to a repository called Staged Recipes on GitHub. You can get it merged in, and then you've got your own Conda package that you can make available to lots of people.
Cool.
And then ultimately it's your responsibility to keep that package up to date. So
the whole world, if you want.
What?
Make the package available too. The whole
world. Yeah. What? Yeah. Cool.